Hello, smart mathematicians. Welcome to our lesson on similarity. We just want to revise similarity here as we start the next section of our Euclidean geometry. Let's just revise similarity and remind ourselves of what we learned in the previous grades. Okay, right. So we're saying that two shapes are similar if they have the same shape but not necessarily the same size. Right. When I talk about similarity, I always talk about, um, let's say, me as a human being and my image. If you check maybe my image and me, we are similar, isn't it? We are similar. Everything there is proportional. Everything there is proportional. Okay. Right. So two shapes are similar if they have the same shape, but not necessarily the same size. One shape is an enlargement or a reduction of the other. Let's look at these quadrilaterals. A quadrilateral is a polygon with four sides. So we have quadrilateral A, B, C, D, and E, F, G, H. What do you observe here if you look at these two? You can see that they are similar, but are they the same size? They are not of the same size. Okay, they are not of the same size. But look at the angles, the interior angles there. You can see that angle A is equal to angle E, angle B is equal to angle F, angle C is equal to angle G, angle D is equal to angle H. What about the sides? What about the sides? What is AB divided by EF? We get 3. BC divided by FG, we get 3. CD divided by GH, we get 3. AD divided by EH, we also get 3. So, okay, let's just discuss these two. Right, so if we check here, angle A is equal to angle E, then angle B is equal to angle F, then angle C is equal to angle G, then angle D is equal to angle H. So we are saying that for similar polygons, the corresponding angles are equal. For similar polygons, the corresponding angles are equal. Okay, right. Let's check the sides. AP over EF is 3, 15 over 5 there. Okay, we have 15 here, and then 5 there. Okay, and then BC over FG again is 3. See that? And then we have CT over GH, 18 over 6 is 3. And then we have the last pair, which is AD over EH, and we have 3. So what can we say about the size of polygons that are similar? The corresponding sides are in proportion. Just remember those two conditions. Okay, right. In order for the two polygons to be similar, the following conditions must be satisfied. So the corresponding angles must be equal and the corresponding sides must be in proportion. But what about triangles? Because we're going to be looking at the geometry of what? Of triangles. For triangles, it's a bit different. Right. So let me explain this. Let's take, for example, a quadrilateral. Let's take an example, a simple rectangle. Right. We can have a rectangle like this. And then this is still a rectangle. Right, these ones they may look similar, but okay, let me use size here. Let's say this is 10, and then this is 8, and then let's say this is 5, and then this is 3. You see that? So according to size here, they are not proportional because 5 divided by 10 divided by 5 is 2, but 8 divided by 3 is not 2. So these are not what? Are not in proportion, are not similar. But check the angles. This is 90, 90, 90, 90, 90, 90, something like that. Okay. The angles are what? The angles are equal, but the sides are not in proportion. So these two are not what? are not similar. You can even have also the ones with different sides. Let me just try to draw a square. Okay, let's say this side is 10, then the square, all the sides are equal, and then I take a rhombus. Okay, let's say this is 8, 8. You see that? So the sides are in proportion. But what about the angles? The angles are not equal. You see that? So for any other polygon, these two conditions must be there. The corresponding angles must be equal and the corresponding sides must be in proportion for the two shapes to be similar. But for triangles, it's what? It's different. With triangles, only one of the above conditions needs to be true in order for the two triangles to be similar. Just one condition. So we're saying that if two triangles are equiangular, it means when the corresponding angles are equal, then the corresponding sides are in proportion and consequently the triangles are similar. Please take note of that. And then again, if the corresponding sides of two triangles are proportional, then the triangles are equiangular and consequently the triangles are similar. So for triangles, we just need to prove one condition, then we'll be done. We just need to prove one condition, then we'll be done. Okay, let's just do a few examples so that you can understand this similarity. Right. Show that the following triangles are similar. So we have triangle ABC and triangle PQR. So we're saying in triangle ABC and triangle PQR. Okay. Right. We can see that angle B is equal to what? Angle Q. Angle B is equal to angle Q. This given there. We're given that. And then angle C. If you check, I'm starting with the angles of triangle ABC followed by angles of triangle PQR. Okay. Right. And then angle C is equal to angle R is given. Right. And then once the two corresponding sides are equal, then the third pair also is what? Is equal. So it means now, therefore, it means angle A is equal to angle P, since it's a third angle of triangle. Right, but even if you use angle sum in a triangle, you can get this. Okay, just say 180 minus 50 minus 35, you'll get this angle. And then 180 minus 50 minus 35, you get this angle. Okay, right, and then now this is triangle ABC if you check, and then this is triangle PQR. Okay, so now we can then conclude and say, therefore, triangle ABC. Be careful there. A goes with P. Is similar to triangle P. Then B goes with Q. B goes with Q there. PQ. And then C goes with R. C goes with R. C is in third position. So R is in third position. You see that? So what's the reason? We say angle, angle, angle. Okay, so the two triangles are similar. And then from this, we just say show that they are similar, but usually from this, just know that therefore, AB over PQ, AB over PQ is equal to BC over QR, is equal to BC over QR, is equal to AC over PR. Then it's equal to AC over PR. Then you write the reason sides in proportion. Size in proportion. Okay, that's done. Right, I have about 4 questions, so we have 3 more to go. Okay, 3 more. Right, what about this one? In triangle ABC, we're given that ED is parallel to BC. Prove that triangle ABC is similar to triangle ADE. Okay, Right, what do we do here? We have to prove that we have three pairs of corresponding angles equal, okay, or we prove that the corresponding sides are in proportion. But here we can use angles because we don't have sides. Okay, let's start with angle A. So in triangle ABC and triangle ADE, we have this angle here, which is a common angle. So for both triangles, so angle A is equal to angle A. We're going to start with angles of ABC followed by angles of ADE. So it's common. And then we come to angle B and angle D1. What can you say about these two? Angle B and angle D1. So angle B and angle D1 there. Angle B is equal to angle D1 because they are corresponding angles. Corresponding angles. DE is parallel to BC. Right, done. Right, and then the third angle now. It means therefore angle C is equal to angle E1, okay? Because third angle of triangle, or even if you use the geometry of parallel lines here, we can see these are corresponding angles. So you can say therefore angle C is equal to angle E1. Right, let's use this reason, third angle of triangle. But even if you used corresponding angles, since DE is parallel to BC, that was going to be fine. Then now we can then conclude and say therefore triangle ABC is similar to triangle. A goes with A, so first position is for A. B goes with D, so second position there is D. Then C goes with E. We managed to prove that these two triangles are similar. Okay, angle, angle, angle. Right. We can even use this one, is fine. Okay, angle, angle, angle. And then just to make sure that we always do this, even sometimes in the exam, just know that when you're given this, therefore AB is equal to AD, AB over AD is equal to BC over DE, BC over DE is equal to AC over AE, AC over AE. Right, and then sides in proportion. Okay, so that's what it's supposed to do there. Let's go to our third example, and then after that we do the fourth one, then we'll be done. Right, in triangle ABC, BD is perpendicular to AC, and angle A is equal to angle B2. This angle is equal to this angle. Okay, angle A is equal to angle B2, given. Prove that angle ABD, that is angle ABD, is similar to angle BCD. Similar to angle BCD. So where do we start? We have our angle A is equal to angle B2. So let's say we're going to start with triangle ABD, the red one. So in triangle ABD and triangle BCD. Right, angle A is equal to angle B2, we're given. Okay, right, and then what can you say about angle D2 and angle D1? They are equal, isn't it? Right, because angle D2 is equal to angle D1, and both of them are equal to 90 degrees. So we can say adjacent angles on a straight line. Right, adjacent angles on a straight line. So now we have proved that we have two pairs of corresponding sides equal. So therefore the third pair also is equal. So therefore angle B1, this one, Oh, this one is 90. Let me just indicate it here. And then this angle B1 here should be equal to angle C. Therefore, angle B1 is equal to angle C, since it's a third angle of triangle. Right, done. So now we can say, therefore, triangle ABD is similar to triangle A goes with B, so B, and then B goes with C, and then C there, then D goes with D. ABD is similar to triangle BCD. We prove that since angle, angle, angle. We prove the similarity. Okay, now you can say, therefore, AB over BC is equal to BD over CD is equal to AD over BD, size in proportion. Okay, right, let's do the last one. Show that the following triangles are similar. So here we're given sides, so we are going to use sides. So in triangle ABC and triangle PQR. Okay, right, you say AB, you can see here 10 divided by 5 is 2, 12 divided by 6 is 2, 15 divided by 7.5 is 2. So you can see that AB over PQ, okay, this side and this side is equal to AC over PR. AC over PR, which is this side and this side, which is equal to BC over QR. Okay, and then all the CV check, they're equal to 2. So all of them, AP over PQ is equal to 2, AC over PR is equal to 2, and then BC over QR is equal to 2. So we can say, therefore, triangle ABC, you check the movement of your from vertex to vertex there, should be ABC is similar to triangle PQR. See that? And then the reason says sides in proportion. Okay, right. Even if you do it the other way around, where we start with the smaller triangle, you can say PQ over AB is equal to PR over AC is equal to QR over BC, and then equal to half. All this is half, this is half, this is half, 1 over 2, all of them. So we say the sides are in proportion, therefore triangle ABC is similar to triangle PQR. Okay, sides in proportion, sides in proportion. Okay, so that's what you're supposed to do there. And then I really hope that you're going to be able to apply this in our next lesson. Thank you very much. Let's meet in the next lesson.